All right, so in Chapter 1, we're going to talk about the way you might process information, the certain ways that your brain works and how you try to come up with a solution to a problem. And so there are two types of reasoning, inductive and deductive reasoning. Now, looking at this example, it says a tourist who visited Key West met a number of people from the Keys who were all relaxed and laid back. The tourist concluded that all people living in Key West were relaxed and laid back. And so we want to consider what reasoning led to this conclusion. Now again, the handout that you have already has this example on there, so you didn't have to rewrite the example. And it might just be left blank for the answer to the question. And so just to sort of help you follow along with those handouts and so on. All right, so this particular reasoning is inductive reasoning. So filling in the blank there, inductive. This is a powerful method of drawing conclusions, however, it's not a fact. Anything you have based on inductive reasoning is not proven to be true. For example, we can always find a resident from the Keys who is stressed out. Okay? It's possible that we'll find somebody who is not relaxed and laid back. So the conclusion that one reaches through inductive reasoning is called a conjecture. You might also call it a hypothesis or an educated guess. Maybe words that you've used in science class. So the conjecture from the last example, so not only do you have that fill in the blank, but this sentence is also not on your handout. The conjecture is all Key West residents are laid back and relaxed. Oh, did everybody get that? I didn't check. Everybody good? All right, so there is just one case that, if there is just one case that disproves the conjecture, then it is known as a counterexample. So that's your next fill in the blank, counterexample. And so the counterexample from the last example, this is also something for you to write down on your handout. A Key West resident who was stressed out. That was something that we mentioned already. If you can find a Key West resident who is stressed out, you have proved that statement false. So notice that you could meet 100 people that are relaxed and laid back, but you still haven't proven that statement to be true. And it only takes one person that's not relaxed and laid back to prove it false. So it's a lot easier to prove a conjecture false using inductive reasoning than it is to prove it true. Okay, so one can use inductive reasoning to identify patterns. So this is where this really is very helpful. Notice we have a sequence of numbers here, 4, 12, 20, 28, 36, blank, and you're looking for the next number. Okay, before we get to the answer as to what the next number is, can somebody raise their hand and tell me what pattern they might see amongst these numbers? Yes, ma'am. Okay, so each number is increasing by 8. Good. And good way of describing it, because you want to describe it in a way that, if the person next to you has no idea what the pattern is, that you're specific. And the more you can do that, the better you'll be able to find hidden patterns in these numbers. Okay, so somebody raise their hand and tell me what the next number is. 44 is correct. Good. A lot of your homework problems are going to be of this nature, where you've given a list of numbers, you have to figure out what the pattern is so that you can find the next number. Now, even though that you're taking your test on the computer, I am going to ask you to show your work on paper. And that's mainly, the computer is going to grade your tests for you. But let's say that, you missed you just made a tiny little mistake on the problem and it marked you all wrong, then I'm happy to look at your scratch paper, but you have to show me some work in order to do that. So, on this type of problem, your work might be, okay, increasing by 8. You say those words. And so it's not always, when you're showing work, it doesn't always mean that you're showing me math symbols on the page. Showing your work can also be telling me what your thought process is. And so if you say, the pattern's increasing by 8, okay, I can see that you had the right intent, and then you add it wrong or something. So then I can verify. Now, just so that you guys know, I only give partial credit to those who actually come and see me in my office hours to say, hey, I think we should review my scratch paper. Okay, so because the computer grades it on its own, it's your responsibility to review your tests and see what you missed and then tell me, what you think, maybe you have an appeal in there. And in the syllabus, I think I noted, that you can appeal and so on, and gave you that process in there. Okay, deductive reasoning is the other type of reasoning. So it's the process of proving a specific conclusion from one or more general statements. A conclusion that is proved true by deductive reasoning is called a theorem. Okay, so an example. The syllabus states that any final average between 80% and 90% will result in a B. If I get a 78% on my final, my overall average will be an 80.1%, so I'll get a B. Is this person correct? How do you know they're correct? Because what? Because the syllabus said that, right? So you're basing your conclusion off what was said in the syllabus, a general statement that you know to be true, okay? And so that's the difference between deductive and inductive. If it was inductive, you might say, oh, well, that student got an 80.1 overall and they have a B, and that student got an 80.1 overall and they have a B, and that student had an 80 point, so then I probably have a B if I got an 80.1. See, that would be inductive reasoning because you're basing it on specific observations. All right, so this one is deductive reasoning. Okay, so we are talking about a specific person and a specific grade, but the conclusion was based on the general rule from the syllabus. Other types of general rules that maybe you don't think about are formulas. If you come up with an answer because you based it on a formula, well, a formula is a general rule that you know to work. Okay, this is the formula for area of a rectangle. I know this because it was proved and the textbook stated this is the formula I'm to use. So that's a general statement that you know to be true. Okay, looking at Math Excel, you see that when you click on the homework assignment, it shows you, a list of all the questions that are in here. The ones that have icons next to them, this means that there is a video that might help to explain that particular question. That's what the film strip icon looks like. There might be other icons because there might be other things that are available for that particular question. Now, if you put your cursor on this question here, it tells you what question it coincides with in the book. So that's section 1.1, number 4. That's what 1.1.4 means. Section 1.1, number 4. Now, if you click on the question itself, then you can also see which question it is in the book by looking in the upper right-hand corner. So right there, where my cursor is, it also tells you that's 1.1.4. So here's the important thing. Being that you're meeting me in class, at the beginning of class tomorrow, I will ask you if you have any questions from the homework, but what I would really prefer is if you tell me which question in the book it is that you need to see, because sometimes the computer's not working, it takes a while to log on to Math Excel, or whatever it might be. I have a textbook in front of me I can easily demonstrate. The other thing, too, is because everybody has the same problem in the textbook. They have that availability to see that same exact problem. Whereas when you pull it up on Math Excel, it's always with different numbers. So Notice in this one it says, find a counterexample to show that the following statement is false. It says the sum of two 3-digit numbers is a 4-digit number. Okay, now I'm going to circle a key word on here. Is. When you're looking at these conjectures, it starts out with some information about the numbers you're looking at, the sum of two 3-digit numbers, and then the is tells you what the result should be. So the result should be a 4-digit number. If you're trying to find a counterexample, then you still want to find numbers that match the first part. So you still want to find two 3-digit numbers, but you want to find two 3-digit numbers in a way where it does not give you the result. Okay, so in this one it says that the sum of every two 3-digit numbers is a 4-digit number. So can anybody raise their hand and give me two 3-digit numbers that does not give you a 4-digit number? Yeah. Okay, so 111 plus 111. So let's type that in and see. So 111 and 111. If you added that together, you would get 222, right? 222, which is a 3-digit number and not a 4-digit number. Now, see, in Math Excel, it does give you a hint. It says, okay, you're really looking for a 3-digit number because that's what, you know. But notice it's not a 4-digit number as explained in the conjecture. So you have just proven that false, which is a counterexample. So any example that proves the statement false is a counterexample. So let's check your answer. Well done. See, and Math Excel will make you feel really good when you finish. So. All right, and then there's more than one answer for these problems. So Math Excel, for the most part, is really good at being able to recognize all answers that satisfy the problem. Now notice off to the right you have several tutorial buttons. You have Help Me Solve This. Help Me Solve This will give you an example, but it'll ask you to do the work as you go. So it'll sort of break it up for you. And so it's really good. It's a good tutorial help if you just really don't know how to do the problem. But it'll prompt you so that you can still do some of the work on your own. Now, if you use Help Me Solve This, though, here, let me go to the next problem. If you use Help Me Solve This, it'll give an explanation. Okay, I'm just going to guess at this. Hey, I guessed right, good. And then you keep going and so on. But once you use Help Me Solve This, then it marks you wrong because it was helping you solve the problem that was there. It now wants you to go back and do the problem on your own without help. So if you ever do get marked wrong like this, then you just need to click similar question at the bottom, which sorry. So it's already given you a similar exercise to work again. Now let's say that I try to do this answer. Okay, nope, I got it wrong the first try. It'll give me another chance to do the same answer. Okay, nope, that's not right either. And I said, are you sure? This is my last chance. See, final check. Okay, sorry, that's not right. And now it marks me wrong and it tells me what the correct answer is. If you put your cursor on it, it shows you what your answer was. And now if you want to redo it, then you have to click on similar exercise again. And then you can redo it for full credit. View an example will be a completely different problem, and it doesn't ask you to do any of the work. It will do all the explanation so that you can just read along, okay, and then you go back to the problem that you were working on. Some questions have videos, not all of them do. If you want to get the textbook page from this section while you're in the homework, you can. You can print your homework. There's a calculator. The nice thing about this calculator is if you only need to do some basic math, it will stay on the screen even if you click back on Math Excel. Whereas if you open up the calculator from your computer, it's going to hide behind the window when you click on something else. Ask My Instructor, I asked you that that's the last thing that you use because you most likely are going to get an answer from one of the other tutorials. But if you click Ask My Instructor, it'll send me an email with the link to the problem you're working on so that I can see it and I can help you. But I'm going to help you by emailing you back, which is not always the best mode of communication on these things. And that's under the intention that I'm going to see the email right away. It might take me a day to see the email depending on when you send it to me. So, so just, you know, try to use all the other tutorials before you use that one because I think your question will be answered faster. Okay, let's take a look at this one. So we have a pattern of numbers here, 6, 18, 54, 162, 486, blank. So can somebody raise their hand and tell me what pattern they see? Yes, Jason.
Multiplying by 3.
Okay, multiplying by 3. What are you multiplying by 3? Okay, well, you're multiplying the previous number to get the next number, right? So it's just, you know, I'm just trying to get you to say it as specific as possible because, again, the more specific you can be, the more you'll understand these patterns and so on. So, and also, again, if you're showing your work, you know, the more specific you can be, the better I'll understand whether you knew it or not. All right, so you multiply the previous number by 3 to get the next number. So therefore, the square calculator might come in handy. You can do this by hand, not too hard, but what would be the next number? Who's got an answer for me? Okay, 1,458. Excellent. All right, so some of the questions, a lot of them are these lists of patterns here, but then some of them will guide you through a process. Here's one where it wants you to repeat the following procedure for the numbers that it gives you. Add the number by 3, double the result, subtract 2, divide 2, subtract the original selected number. Okay, so the first number it wants you to use is the number 2. So we're going to take a 2. We want to add 3, so we get 5, double the result, so what am I supposed to do? Okay, it gives me 10 because I'm doubling it, multiplying by 2. Okay, subtract 2, so I get 8. Divide that by 2, and that gives me 4, and then subtract the originally selected number. So in this case, the original number was the number 2. Okay, so subtract 2, and I get 2. So that's my answer, and so I'm going to type my answer into the box. Okay, so typing in a 2. Excellent. So now we're going to do that again with the number 6. Okay, so 6 plus 3, 9, times 2, or doubled, 18. Subtract 2, 16. Divide by 2, 8. And then subtract the originally selected number, which was the number 6 this time, and we get 2. Okay, we got 2 again. Okay, so type in a 2. All right, next number is 7. So what is 7 plus 3? 10 times 2, 20, minus 2, divided by 2, and then subtract the original number, which was 7, and we get 2. Okay, do you notice a pattern so far? Okay, what reasoning are you using so, you know, to notice that pattern? You have a 50-50 chance at this one. Inductive for looking for a pattern. Okay, so if notice we're just trying specific numbers and we're looking for a pattern. So far it's inductive reasoning. We're just trying out certain things to see what we get. So what do you think this answer is going to be? 2. Okay, let's see. Excellent. Okay, so now, yes?
Why wouldn't that be deductive if they gave me the 20?
Okay, so it's not a formula per se where there's a variable to substitute into and work out your answer. It's just follow these steps and see what you get. So it's not telling you what your answer will be, it's just telling you what to do. Okay? You see, now hopefully when we do the second part of this question, you'll see the difference. So now it says, write a conjecture that relates the result of the process to the original selected number. So what do you think the answer is always going to be? 2. So your conjecture would be that the result is 2. So you're typing in a 2. Now, let's say that you always come back to the original number. So maybe when you did a 2, you got a 2. When you did a 6, you got a 6. When you did a 7, you got a 7. So then you could say, well, you can use a variable then. You say if my original number is n, then my answer should also be n. Okay, and that would be your conjecture. So sometimes you will use a variable in that part of the answer. Okay, so correct. Nice conjecture. Now we are going to use deductive reasoning by picking a variable, the letter n, and seeing what happens as I work through it. Now the reason why this is deductive reasoning when you pick a variable is because you're doing this procedure now for all numbers. You're saying this is what's going to happen for any number, not just the 4 specific numbers that I picked. Because maybe it's possible that there is one number that doesn't work out there. Okay? All right, so if I choose n and I add 3, then what do I get? N plus 3. So type in n plus 3, hit enter. If I want to double my result, okay, so this is a common mistake. Careful when you're doubling, you're not squaring, you're multiplying by 2. Good. Okay, so so I heard a couple different possibilities. I heard 2 parentheses, n plus 3, close your parentheses. You can multiply the whole expression by 2. However, notice right next to my answer box, it says simplify your answer. Well, that means then it doesn't want parentheses, because if you have parentheses, there's more you can do to simplify it. So instead, you could distribute this, and you would get 2n plus 6. You got to double both of those terms. Nice work. Okay, subtract that expression by 2. Right, because essentially you're just saying, you're just doing this. I'm subtracting 2, but I have to do it from the like term. Okay, so 2n plus 4 is correct. Excellent. Now divide that expression by 2. Remember, when you divide the expression by 2, you're dividing the whole thing by 2, which really means that you're dividing each term by 2. So n plus 2. Good. And now subtract the original number. What was the number we started with for this particular problem? N, right. So, okay, the original number was n. So we are subtracting the original number of n. So what happens to those n's? They cancel out, and I'm only left with a 2. So notice that this was more of using a formula now to do this. I have just proven for all real numbers n that I get an answer of 2 every time. So whatever I plug in for n, it's going to work. So that's why that part is deductive. The first part's inductive, second part was deductive. All right, and then you'll have some other problems, like maybe looking at, a pattern and, answer these equations, do the actual multiplication, see if you notice any patterns. You might be asked to create the next line based on the pattern, and so on, just all, different kinds of problems like that. All right, so I'm going to move on to the next section, which is section 1.3. Section 1.3 is problem-solving strategies. You're going to see more applications in this section, so applying certain strategies to different math problems. Now, it doesn't matter if it's a math problem if it's a social problem, if it's an everyday problem. Your brain actually processes the same steps. So the first step that you would have to do is understand the problem. Now, if you took me for intermediate algebra, then you've already sort of heard this speech before. But basically, let's say that my problem is getting dressed in the morning. So I have to understand the problem. All right, well, understanding the problem, I'm going to go to work, so I need to pick something appropriate for work. That's understanding the problem. Okay? Your brain does this automatically for you. Only because when you were little, your brain didn't process it, right? You trained it, okay, and you understood that as you grew. So in math, that means read the problem several times and write down the given information. So for some of you that you don't feel like you're great at application problems, it's really just a matter of training yourself, because your brain is a muscle. You have to train it to do certain things, okay? The next step would be to devise a plan. So, okay, if I'm getting dressed in the morning, then I might say, okay, I'm going to walk over to my closet and pull out clothes that are appropriate for work, and then maybe find stuff that matches, okay, as a bonus. All right. So I've devised my plan. Again, in the course, you might use inductive reasoning for pattern recognition, just like what we did. Look for a pattern. Maybe you'll make a table or a list, use estimation, use trial and error, simplification. There's so many things we could list here for devising a plan. One of the things I didn't write on there was identify a formula. Maybe you need deductive reasoning and using a particular formula. And drawing a picture, because maybe it tells you that you have a rectangular swimming pool. So you can draw a rectangle, and it's going to give you dimensions. Whatever you might do is part of your plan. Okay, the third step is to carry out the plan and solve the problem. Okay, so if my goal is to get dressed in the morning, what do I have to do to carry out and solve the problem? Get dressed, right? Okay, so it's simple. So again, I'm just showing you how these steps are not new. It's something that we do every time we have to solve an issue. So in this course, maybe you create an equation and you're actually going to solve the equation you created. Maybe you found a formula. Well, you're going to substitute your numbers into your formula and you're going to solve it. Maybe it was just finding the pattern. You found the pattern, and now you just have to apply that pattern to find the next number. All right, so that is carrying out and solving the problem. The last part is to look back and check the answer. If I'm getting dressed, how can I look back and check the result? Look in the mirror. Okay, again, see, all four of these steps are part of what you all do all the time to solve any issue. All right, so sometimes we forget to check our answer, and we make a minor mistake, okay? There might be a couple of you guys that forgot to look in the mirror today, okay? So, there's something you missed there. All right. A couple of the questions that I like to ask myself when I'm checking my work is, does my answer make sense? So maybe you were looking for the capacity of a soup can, and you ended up with 1,000 gallons. Okay, look at the number. Okay, that doesn't make sense. It's a little soup can. So check that as your work. The other thing is, did you actually answer the question? So maybe you had the dimensions of that swimming pool, and they asked you for the width, but when you solved your problem, you ended up L equals 15. Usually L stands for the length, and you stopped and you didn't go the next step to find the actual answer. Okay, so these are questions you want to ask yourself when solving the problem. All right, some of the questions in your homework are not going to necessarily ask you to solve it. It's going to ask you to identify any missing or unnecessary information. This is part of training your brain to identify the most important part of your problem. So a man purchased 5 shirts, each at the same discount price. How much did he pay for them? Now, normally, if you're going to look for missing or unnecessary information, you're actually probably going to run through how to do this problem in your head, because you're going to try to solve it and say, oh, wait, I'm missing that, or, oh, I never even used that number. That's unnecessary. So the first thing you might want to do is write down the information. That's step 1. Read the problem and write down the key information. I had 5 shirts. Okay, to solve this problem, if I was going to find out how much he paid for them, I would need to take the 5 shirts, and if you find out how much you paid for stuff at the counter, you take the number of shirts and you multiply it by the, okay, so just, just how much they cost, right? You take how many you have and multiply it times how much they cost. So the amount the man paid for the 5 shirts is the number of shirts times the cost of each shirt. So you sort of have to think about that before you can figure out if there's something missing or unnecessary. So that is devising my plan, working out how I would solve it. So can I do that? Can I take the shirts and multiply it times how much they cost? No, why? I don't have the amount that the shirt costs, right. So I know that they were at the same discount price, so I know they're all the same price, but I don't know the actual price. So I have missing information, the cost of each shirt. So if it's missing information, they'll ask you to identify that and then move on. If it's unnecessary information, they may ask you to identify that, but then they might still ask you to solve the problem, because obviously you have everything you need. You just had extra stuff that you didn't need. Okay, a roll of easy white paper towels contains 100 sheets and costs $1.38. A comparable brand, Quick Clean, contains 5 dozen sheets per roll and costs $1.23. So comparable, however you pronounce that. If you need 3 rolls of paper towels, what brand is the better value? Okay, this is a very popular type of question in this textbook. What is the better value? And so whenever you have a problem that's asking you for better value, you have to identify what information you have, but then you also have to be able to compare the price to the same amount. Okay, or you might call that the unit. So you want to take a price and compare it to the same amount per each item. So you have this paper on your, or you have this problem on your handout. I'm going to switch the screen, but the first thing you need to do is read the problem again and write down the key information. Okay, so we're understanding the problem. Okay, so here's what's given. We had 100 sheets per roll at $1.38, and 5 dozen sheets per roll at $1.23. If you want to write down what brand each of those were, you can as well. And then we need 3 rolls. That's the information that was given.
Could you just go ahead and multiply the 5 dozen, the 5 times the dozen?
Okay, so think about part of your, why would you multiply the 5 times the dozen? Tell me what your thinking is.
How many sheets there are to compare the 100 sheets per dozen.
Okay, good. So you want to multiply the 5 times 5 dozen, 5 times 12 to see how many sheets there are, so you can compare it to the 100. So all right, so, okay, so yeah, that's definitely one strategy that you can take, because you want to see how many sheets you have at that price. And then, so what is 5 times a dozen? 60. Okay, so do you have the same amount of sheets at this price? No, so you're still not comparing the price to the same amount. So what can we do instead then?
I guess multiply the dozen to see how much you can get back to equal up to the 100 sheets.
Okay, so there's a couple ways you can think about it. You're trying to see how many more dozen you need to get to the same amount.
Yeah.
But if you go by dozen, will you ever get to exactly 100?
No, you get more.
Yeah, you'll get more. Yep.
I would calculate the 60 times, I would do it 3 times, $1.23 times 3 rolls.
Okay, because you're getting 3 rolls. Okay.
I would say I'm getting 180 sheets versus 300 sheets.
Okay, but you're also getting 3 rolls of the 100.
Yeah, for $4.
Yeah, so you still won't quite have the same amount. But, so now, both of those strategies were to maybe look to get more, you know, amount, a higher amount in each. But what if you went backwards? And you went, well, how much would just one little sheet cost? And so if you could figure out how much one little sheet of paper is, then you can compare it, the price, to the same amount. Okay, so essentially, we need to find the cost per sheet. And in any of these better value questions, you're always getting the price per unit. So you want to break it down to just one item instead of several items. So what is the price per that one item? So it doesn't matter what type of question it is. Think of what price per unit means. Per is usually that slash, which is like a division symbol, right? And so you're taking the price and you're dividing it by the number of items you have. In this case, it's sheets in a roll. But if it's any other type of problem, you know, it could be other items. You know, maybe it's, you know, 12 pens in a box. You're dividing it by the number of items you have. So now you know if you have a better value problem, this is the format you want to follow. So you have one strategy down for these types of questions. Okay, so now we have already figured out how many sheets are in the 5 dozen, which we needed to do. So 5 times 12 gave us 60. So now we're going to actually carry out the plan. So help me with the information since it's off the screen. So for the first brand, the 100 sheets, what was the price? $1.38. Okay, so we're taking the price, $1.38, and we're dividing it by the number of sheets in the roll. Okay, dividing by multiples of 10 just means move your decimal over the number of zeros. Okay, so hopefully you get 0.0138, and so this means that it's a little more than a penny per sheet, right? The dollar per sheet, because that's what we were dividing by. So the other one, we figured out that 5 times 12 gave us 60 sheets. What was the price of that one? Okay, so we have 123 divided by 60. And what do you get on that one? 0.0205. Okay. Sometimes it's useful to bring it out a few decimals, because if you get that they both are equal to a penny, you need to know, well, how much fraction of a penny do you have in there to compare? Okay, so this one is about 2 cents per sheet, and this one is less than 2 cents per sheet. So which one is the better value? Okay, the one that comes with 100 sheets in the pack. All right, so this one is lower, so that is your better value. So if I go back to homework and tests, and I choose section 1.3, notice it's a much shorter set of questions. So every homework set has a different amount of problems in it. And notice, here's a new looking icon. See these little purple, like, squiggly arrows here? Let's go ahead and jump to one of those questions. So it says a television sells for $600. Instead of paying the total amount at the time of purchase, the same television can be bought for paying $150 down and $50 a month for 14 months. You still have, it says how much is saved by paying the total amount at the time of purchase. You still have, to help me solve this and view an example, you still have a video. And the video, by the way, is a particular instructor who is working out the problem, like on a document camera like this, you know, on paper, and working out not necessarily this problem, but something similar to it. So it'd be something similar to like what you get to me. The animation is actually...
Your goal in this activity is to solve a real-world application using a
little bit
six-step
more
approach.
computerized and
In May,
try to be a little
landlord
animated
received $720 from each of 8 tenants.
And then see, it prompts you to go to the next screen.
After paying $2,180 in expenses, how much rent money did the landlord have left?
Okay, so it's just working through
problem
the
states
problem,
how
but
much
it's
rent is
animating this
collected.
picture for you.
After expenses have been
I'm not going to go through the whole thing, I just wanted to make you aware of what that meant down there. Okay, so again, you've got several different types of problems. Also, don't forget that there are examples in the book. I know there's a book for the course. I just want to remind you guys of that. There's a book for the course. Hey, and I typically do not do the examples in the book because then you'll have another example to go to. So if you go to the textbook, it brings you right to section 1.3. It has the steps that we talked about on there. But then let's say, so this particular PowerPoint did have some of the same examples in it. But let's say that you wanted to see an example of, you know, solving a problem, making a list. So it gives you another strategy that you can review in here as well. So make sure that you're paying attention if you're stuck. There are lots of places where you can look for help.